So first and foremost, can you, let me make sure I turn, I'm gonna mute myself in between the questions. But first and foremost, can you tell me your name, spell it for me, and then also tell me your position at MSU?
Okay, so my name is Muhammad Rabnawaz, Muhammad. Last name Rabnawaz. I'm an assistant professor in the School of Packaging, adjunct physician assistant professor with the chemistry department in the Michigan State. And I'm also the principal investigator of the Sustainable Materials Research Group.
Okay, all right,
Yep.
perfect. So my first question, tell me about this, your research that you're doing. First of all, let's start with why is plastic like not good for the environment? So just break it down for people who may not understand.
Okay, and there is something we really need to do a good job there. So plastic is a human-made material, and it is used for enormous applications. In the United States alone, 70 billion pounds of plastic is used every year. But as I mentioned, it is human-made material. When it goes into the environment like water, soil, the bacteria doesn't know how to digest them, how to degrade them. So when plastic leaks into the environment due to the exposure with the sunlight and abrasion, it converts into tiny particles, like 1/8 of an inch. And those particles are shown to be loaded with toxic materials because in the ocean we have toxic chemicals. They get into those microplastics. Now, those microplastics, they can be eaten by plankton, and plankton become food for ocean organisms. So they are, in fact, damaging the ocean organisms. But now think about the human being. When we eat fish, and if it has eaten that microplastic that is laden with harmful bacteria and toxic chemicals, it comes to us, contaminate our food chain, right? So it's really bad for the environment and human health. And that's why plastic is now a big problem. It's posing a big problem to the environment and human health.
Okay, perfect. So talk to me about your research. What are you doing to kind of tackle this problem? And also break it down like as if I'm a 2-year-old, so people who don't understand can kind of really understand.
Okay, sure. So in the School of Packaging, with my colleagues and students, we are working to address the plastic waste problem from multiple angles. One aspect is to find new market, new value for the recycled material. So a plastic that is discarded, can we convert that into something useful product, like making a new package, making some engineering parts for the automotive, for construction, right? Now, it's going to help the environment in two aspects. First, when we use recycled material, right? So we are reducing plastic waste in the environment, in the landfill. And second, we need less new plastic to be created in industries. So it prevents the creation or minimize the creation of virgin material. So there are multiple benefits for the recycled plastics. Another aspect that we are looking into is to improve plastic recycling by using the same material for multi-purpose usage. Like the milk bottle plastic, right? If we can use that for engineering applications as well. The importance of this one is later on, you have few material to recycle. Rather than you have hundreds, you have now 20 or 10 materials to recycle. They are easy to separate from each other, and then one can use them for the new applications with a lot more ease compared to what we do now. And another aspect that we are looking into to promote recycling is some plastic these days, they are, even if you collect it, you cannot recycle it because they are made of 10 different types of plastic. You can't do anything with that. So we are trying to find simple design so such that you can easily recycle it. One example is mylar bag. Mylar bag with the metallized layer on that one, and they are extremely challenging to recycle. So we are trying to, hey, can you eliminate metal and find another kind of species where you get the same performance, but you can easily recycle that one. You can, if you want me to repeat certain question, I will be happy to do it. So don't worry, I have time, okay?
Okay, no problem, no problem. So tell me, I read in the article you were doing something with polymers. Kind of talk to me about that. What exactly is a polymer and how are you using that to kind of tackle this?
Yeah, sure. So polymers are large molecules combining millions of small molecules together like a thread. And thread like spaghetti, when they entangle with each other, that's why you get the mechanical properties as well as flexibility in the polymer, right? So that entanglement is very important when it comes down to the plastics. What is the drawback of the recycled material? When you are using plastic, it passes through certain processing and those things, and during the usage as well, some of the chains, the threads, breaks down. Now, when you recycle the material, that material is typically has low performance. Now, my research is looking into to repair those threads of the polymer again to get virgin material-like properties. This is what we do.
Okay, perfect. And how's that been going so far? What have you found out so far from your research?
Well, so the initial research is very promising so far. We love where we are. We are on right track to achieve our milestones. So we have bigger milestones. I'm going to talk about that in the next one. But we learned that plastic recycling, if we want to promote that, we need to have coordinated efforts between academia and industry. It is a problem. It is a wicked problem. We need to solve this by engaging the stakeholders.
Okay, perfect. And tell me, how do you think that your research or whatever you guys find out at the end will really, help the environment?
So yeah, there's a good question. So I think down the road in the next few years, we are expecting that our research will help to divert over 10 billion pounds of plastic per year from the landfill into the manufacturing. Now, if you look into the dollar value of this, it could be alone $10 billion or more. But the environmental benefit will include the reduction of microplastic that are created and posing problem in the ocean, right, to the ocean organism and in the Great Lake here. So we are addressing that problem through this research. Another important thing that we need to consider that when we recycle material, right, we cut down the CO2 emission. And for a 10 billion plastic, if it is pounds recycled, if it is recycled, it is going to help reduce the CO2 emission by 24 million metric tons a year. So that's going to help the US narrative and vision for a carbon neutral mission down 2050,
Okay, so you seem very, very passionate about this. So tell me, why is this so important to you? Why do you feel this is necessary?
Well, so we need to look into the role of the plastic, right? Plastic, a great material, is keeping our food safe and our medicine safe. Believe me, if there was no plastic, we will have more deaths due to a lack of medicines to reach out to the poor nations in particular, and there will be more hunger. So plastic packaging is really important. Imagine one example, look at the mask that we have in the pandemic. It's saving lives. They're all plastic-based material. So plastic is important material. Now, the thing is we are now in a situation, either we go to stop using plastic or find a way to keep using it but in a sustainable way to minimize or eliminate the problems, the pollution. And that's why I'm thinking about this. Hey, we need to live with the plastic because it's a great material, great benefits, but we need to find a way to minimize and eliminate the problems associated with the plastics.
All right, perfect. And my last question, this wasn't on the list of questions, but it basically it's just talk to me like talk to me about your day. Like when you go into these lab or when you're working with your research team, what is it like? What are you guys doing? Like tell me, like take me through every step process that you guys are doing.
Well, so technically my day starts at 6 a.m. in the morning, and uh, I'm always so excited to jump off the bed, start my day. I work on my computer for 3 hours or so, and then visit my lab, meet my students there. During these early 3 hours, I just give them a message. What are the top things? What if they have any data they want to share with us, because we need to look into the data. We are scientists. We believe in data. We look into the data, and based on that, we move forward. And I visit my students to see how they are doing, give them encouragement, see the samples myself. We do sometime online, like WhatsApp and those kind of video things as well. To be more time efficient. So, and then after those visits at the lab, I do meetings if needed with the students. Eventually, my day starts at 6 a.m. and then ends typically at 6 p.m. And sometimes we spend a couple of hours in the night as well, like 8 to 10 to do more work. So being a scientist is a life which is more about the passion, right? And we don't feel that we are spending that much time because it's our passion, and that's how the passion is. You do things, you don't feel that you are doing it, right? You don't think about how much time passed. So yeah, it's what we do.
So when you what kind of samples are your students showing you? Does it have to do with your research with the plastics, or is it something different?
Yes, they are showing sample with the plastic to me, like, hey, we recycle this plastic, and we then compare that with the performance of the virgin material. And the idea is, can really we recycle plastic and bring it and make the performance equal or exceeding that of the virgin material? So we are looking into those aspects, because if the performance is not there, then the industry is not going to reuse this in their products, right? So that's what we are looking at.
Okay. All right, perfect. And so the same thing with the data, they're bringing you that similar data as well.
Yeah, so there are physical samples we look into, and there are data that we have, weekly meetings as well. We talk about the data. We look into a different impacts, like how because recycled plastic comes with a lot more problem, especially the performance is not good, there are impurities. So we need to figure that one out. The things are usually not straightforward. So I will say the credit goes to my students who are doing great job in the lab, and putting their time and efforts there to solve those problems.
And at the beginning of our conversation, you mentioned that you really want to teach people. It's so important to teach people about this stuff. So kind of talk to me about that. Why is it so important for people to understand either how plastic works, or how understand how plastic works, or just how it's hurting the environment and why this needs to change, basically, if that
Yeah,
makes sense.
yeah, absolutely. So I think it is very important to educate public, because if we educate the community, and they can do more and more recycling. So if you have recycled material, then the industry will be open to put them in the product. Because for any commercialization, you need an adequate supply of the raw material. So we are basically putting the recycled plastic or the plastic waste into, like, as a resource, as a raw material, right? So there's, if the community is engaged, they will put more and more the plastic waste, the plastic that are recyclable in the recycle bin. And then there is a system, there are material recovery facilities, they separate the things, and then the plastic can be reused. So we really want that the consumer particularly, right, they should play their role. They should put more and more recyclable plastic into recycle bin. So we are looking into their cooperation. And on our end, being educator, we really need to do a good job to educate the public. Many people don't know like what is recyclable, what items can be recycled and what not. So that's the thing that we need to, as an educator, we are working on this to approach schools. So we are targeting elementary, middle, and high schools to reach out to the kids. And through kids, we want to educate their families as well. Hey, recycling is great. It's going to help to pay off in many ways. It's good for the environment, good for the economy. So we are approaching the students, the school students, because they have more power on their parents and they can convince their parents, hey, do those. And one thing that I want to tell you that we not only do research to solve this problem, but we are generating a whole new generation of scientists who will handle the plastic recyclability problem in the coming decades. So we are training new generation of scientists. And I'm also training and educating industry professionals how they can do a good job now to reduce plastic waste, because it is also built in the how we recycle a package, how we build a package that can be easily recycled. So we are on my end, I'm educating students to prepare them to be a scientist and help the plastic recycling mission, but I'm also educating the industry professionals.
All right, yeah. Perfect. Is there anything else that you'd like to add that I didn't ask you?
No, I think you did a good job. I hope you find you find the answer that you were looking for. What I can do basically, I can send you this one. That might be helpful for you as well. You can look into and you can get some points from there.
Yeah. So definitely just send me any pictures, photos, even pictures of like the plastics that you have, that you guys have analyzed or created, different stuff.
Sure.
That'll be great. And then let me just make sure I have all my, when did you guys start your research?
2016. So let me send you my very one paragraph bio as well.
Okay, yes.
Okay,
yes.
And you will find my position and what I do in a little more in detail, okay?
Okay, and then also, how long do you think that all of this research is going to take until you guys kind of reach a milestone? You think it's going to take a lot more years or a little bit more?
I will say, to be more optimistic, 5 years.
5
That's
years?
what we are looking at, yeah.
Okay, all right, perfect. All right,
yes.
Those are all my questions for today. Thank you so much for your time. When I finish putting everything together, I'll send you the link to the web article and also the video.
Okay, thank you, Yamari. I really appreciate this.